So, right, friends, now we move on to the second presentation of this session. And everyone associated with the industry, whenever we hear the word LNG, so we get excited. And I think I have the privilege now of introducing my fellow co-panelist, Mr. Julian Terpes. He is the product development manager at TG Gas Engineering, based in Germany. He is responsible to develop and innovate TG's offering to the market. He has received a degree in mechanical engineering, thermodynamics from the RWTH, Aachen University in 1999. Since that time, he has worked for many years as project engineering manager in different international projects related to liquefied gas. Later, he was leading the Department of Project Engineering Management at TG for several years. During these assignments, he gained extensive experience in the portfolio technology, management, and execution of EPC projects from proposal to commissioning, as well as leading product development projects. During the lunch, when I was interacting with him, I came to know that he has traveled and worked in projects in major economies like that of Europe, China, and he spent a lot of time in Russia in doing many projects. And presently, he's busy developing a product. So let's hear him out and understand what all he and his company are doing. So over to you, Mr. Julian.
Thank you very much.
Can we have a round of initial welcome applause for him? Yeah, so thank you.
Thank you, Amit, for your kind introduction. Yes, as you can see, I come from Germany. I'm not Indian. And I'm very pleased to speak to you today. Yes, subject of my presentation to you is related to LNG infrastructure. Also, this morning I already perceived and heard that developing infrastructure is very important here in India, and TGE Gas Engineering, as an experienced EPC contractor in this field, is active for 40 years in this field, and I would like to introduce you and give you some insight into the technical aspects of modularized solutions in this field. Some words at the beginning to TGE Gas Engineering. A company founded 40 years ago in Germany, had some stages via Suez, Tractebel in France and Belgium, and is now part of the CMC group to 60% and 40% to Gasfin. TGE is mainly acting for the moment in Europe, China, very experienced. Also, we do have an Indian office in New Delhi. We are active in Russia and also seeking for extension to Southeast Asia. So as EPC contractor, TGE started in the petrochemical business, so ethylene, ethane, LPG, ammonia terminals, and around about 20 years ago, the business to LNG was entered. For both LNG and for the other business, as you can see, there is experience about 3 million cubic meters installed capacity, liquefied gas installed capacity. There are different storage concepts available that depend on the individual case, which makes the most of the sense in terms of the transport logistics. So left-hand side, you can see the most common storage concept, that is the atmospheric storage that you can find in 3 different safety levels, such as single containment, double containment, full containment, which is today the state of the art. There you can see, meanwhile, storage tanks of 200,000 cubic meters storage each. You find the spheres well known in the middle, also semi-refrigerized storage, semi-pressurized storage. Means that it is pressurized but cold at the same time. Then the 4th pictures from the left, you see satellite stations for LNG, and right-hand side something which is not so much related to LNG. Those are the very safe pressurized earth-covered storage tanks. There are, as you can see, 17 projects executed. There's a model of EPC, doing full EPC, so turnkey solution, but also in some markets such as China, very common is the EP solution, where TGE provides the technology and the main procurement, and also supports with the construction, supervision and commissioning. Some definition about small-scale LNG. What is small-scale LNG? There is no international standard of categorization. However, you can see in the market, and TGE also made the definition for 4 different ranges. In LNG, LNG started with world scale actually to transport the LNG via the oceans. So on a very large scale, storage capacities of 300,000 cubic meters in that region, or here better in annual throughput, so a number of 2 million tons per year LNG. This is a world scale. Mid-scale came then about 20 years ago, less than 2 million MTPA. We define that. Small-scale LNG is not so small, still up to 0.5 million tons per year. And the smaller things such as fueling stations, for example, we call LNG as fuel. For LNG production, we do have a bit different ranging. This is due to the different technology jump between the categories. But nevertheless, this is TGE definition. We see it also aligned to some other companies in the market. So today, in this presentation, we deal with small-scale LNG. There are different solutions which we see growing market demand. Mainly the demand for power generation. So small-scale LNG to power is a very important subject in Asia in general. But also the second one, as you can see here, is bunkering and distribution plants. So send it via ISO container and to further end consumers, to satellite stations, or do ship fueling. And there are meanwhile the emission control areas in the world where diesel oil with or heavy diesel oil with significant sulfur content is not allowed anymore. So there are several ship operators already switched to LNG as fuel. The third one you see here is related to LNG production plants. There at the moment we see a very competitive LNG market price from the United States. Also Russia has a lot of plans in the near future, in the next decade, to export more LNG. So this will lead to the expectation of lower LNG prices in the future. And this is not so much at the moment favorable for investing in small-scale LNG production plants, because still you have some complex technology to apply. We heard already the biogas presentation. There's some pre-treatment to be done, and here for liquefaction there's even more to be done in terms of CO2 removal, water removal and other removals. And then still the liquefaction process. So at the moment we do not see that so much demand due to the low world market price of LNG. So depending on the capacity and the case, there are different solution develops, which are typically the most appropriate solution. Here you see a modularized pressurized terminals consisting of vacuum insulated pressurized bullets. State-of-the-art are storage tanks of 1,000 cubic meter each. Advantage here of the system is also that it can deal with the storage for several months without boil-off gas handling. As you may know, due to the heat ingress into the storage tank from the environment, some boil-off gas will be created at minus 160 degrees Celsius storage temperature. So here in this case, the tank can take it by pressure over time and does not need boil-off gas handling. Here also part of such terminals is an ambient air vaporization system. You see here in the middle, and fully standardized prefabricated solutions, including loading facilities for ship unloading, but also vaporization facilities here, for example, in case of LNG to power. The other concept is then the atmospheric storage. As shortly introduced already, we do have single containment, double containment, or full containment. Single containment is the quickest one in terms of installation. There are several single containment tanks in the world in operation, so this is a safe system, but nevertheless in very populated areas nowadays, authorities like to see a full containment solution, which is absolutely state of the art. Also here, as you can see here, this is a very standardized and modularized design approach. This type of storage is usually applied for storage capacities above 10,000 cubic meters due to economy of scale. For smaller terminals, this would be just more expensive as the pressurized solutions. Other difference here to the pressurized solution is here you see also the requirement of BOG handling. So there are compressors that can compress the gas and bring it directly into the pipeline, or have it to liquefy, depending on the case. So the modularized design approach is not necessarily leading to a prefabrication of a module, but allows it certainly. All engineering is structured in a way that all the plant areas have their own engineering documentation and handling. So for the tank system, we have the vacuum insulation and the different tank types. For vaporization, there's the possibility to take the cost-effective ambient air vaporization as standalone solution, or in other cases, if this is not possible, submerged combustion vaporization by burning gas, which is not favorable for OPEX, but maybe the only feasible solution, or the ORV solution using seawater as heat source, or the cogeneration vaporization. So in case of LNG to power, this is a very effective way of synergies by making use of the waste heat of the power plant for regasification purposes. Also, the interconnections are standardized, can be prefab or built in situ depending on the case. Tank platforms on the tank roof. In case of need, as explained before, the BOG compression and recondensing. Also, in some cases, you will have external pumps in case of higher pressure requirements. So those things are standardized in a way that the project can very quickly be started and does not need to be in a very project-specific way to be analyzed and will consume a lot of time for engineering. We also have some buildings such as control building and substations, utilities that can be fully prefab. And certainly in case of a need, also ISO container loading, truck loading. Meanwhile, we also see some growing demand for rail, LNG on rail in Europe. This can be also something in the future for longer distances. Can be equipped the plant with such facilities, and certainly metering if we talk about regasification. So we have standardized 4 cases. The first 3 are related to LNG to power. This gives you a bit an idea for what power demand, what sizes of LNG terminals would be required, and what the outline delivery time and right storage concept would be. So if we have in a remote location electrical power demand of 150 megawatts, for example, we talk about 1.2 million tons per year of LNG in case of quite full load operation, as you can see here from the notes. very small ranges in the range of 25 megawatts. We only need storage capacity of 6,000. There we are still with vacuum insulated bullets. If we go higher, we usually would go for the atmospheric storage tanks. The delivery time is something, in good optimistic cases, about 2 years. So now how those terminals would be constructed in a very remote area. Not everywhere you have the construction people qualified and everyone on site. So it must be a very reliable execution with the need of remote construction in a shop. So you see first the plant is prepared by doing soil improvement and possible pile construction, whereas meanwhile already in case of a prefabricated solution, the production of the modules can be started in parallel. So meanwhile, the storage tank is built in situ already. That has to be in situ. Usually such sizes cannot be so much prefabricated. The modules can be produced and delivered here by a barge. The idea is to have the full plant modules on one barge. On the carrier, there is a roll-on, roll-off solution where the ship crane puts the modules on the roll-off. So the roll-off transporter brings then the modules into the plant area at the dedicated position, more or less, not yet finally adjusted, but close to the final destination. Then usually the transport is expensive, so this procedure should take as short as possible, and the carrier can then disappear. And then the local mobile cranes will put the modules into their dedicated position. All the modules have been then shop fabricated and tested beforehand, so that there is then needed only a minimum of field construction. There will be some side field joints which are minimized, so welding connections that need to be tested certainly. And what also has to be done on site is the cable pulling interconnection, whereas the modules itself are already fully cabled. And then the final site completion, including commissioning. So some project example. Here you see an example from 2003. This was the first LNG small mid-scale distribution terminal in China. That time in combination with the production plant. That time the LNG was difficult to be imported to China. So this solved really the chicken-egg problem in China of the infrastructure. So there was no pipeline, nothing, and the trucks you see here traveled about 4,000 kilometers between Western and Eastern China to bring the LNG produced in Western China to the eastern coast. This is a 30,000 cubic meter storage tank. There also has been designed at that time and constructed a rail loading terminal as an additional option. However, also to be mentioned, in China this was not allowed to be operated later on, but for example in Japan this is also a solution that is in operation for 20 years now, LNG on rail cars. On our booth, TGE has a booth here in the exhibition hall here on the left-hand side. We have more information, certainly if you're interested we can go further into details here. Some general investigation that should be done prior to project execution to have the best execution concept for the project is, do we go for maximum on prefabrication of the designed modules, or will we also go for stick-built concept? And certainly to be assessed are the construction risks, the local construction risks, which depend, for example, on difficult weather conditions, but also sometimes we have high local labor cost. We have sometimes challenging local regulations. So not only talking about infrastructure in India, but maybe also some countries around. There might be the better choice than to produce something, prefabricate something here in India and export it then. Also in terms of project duration, we see the prefabricated concept in favor because of the parallel construction. And also tight plot spaces, which makes it difficult to handle all the detailed material, makes it favorable more for the modules. Whereas sometimes there's a customer wish of very specific solutions, changing and discussing the design. In those cases, the stick-built concept would be easier because it allows more changes still during project execution. And also in case of constraints of construction, heavy lifting equipment you need for the modules, then you may need to go for the stick-built concept. Summarize the key success factors from the modularized solutions is safety. It's a very important point. There's no need to have so much scaffolding on site and to control site safety outside, but you have a controlled workshop area. This becomes more and more an issue all over the world. It is, as mentioned before, fast. It is a reliable solution, is a proven solution, not depending on new companies doing certain things as the first time. And we, as presented, also see it as very cost effective, particularly also due to the short implementation time. Last but not least, it's an opportunity also for Indian companies to support by prefabrication and export such solutions to other countries in Asia. I would say thank you very much. If you have questions, please, you are very warm invited to our booth here the next 2 days. I'm there with my colleagues here.
We definitely have time for one question. So I think if there's any query, I can see a hand, so we'll take your question. The mic should be there somewhere because it has not come back to me. So.
I saw in your presentation you show a couple of examples where
you'll have to keep it closer to your mouth.
I saw in your presentation couple of installations where you have shown bullets of over 1,000 meter cube size, 1,000 meter cube, more than 1,000 meter cube.
1,000?
Yeah, that's what I saw. You mentioned in your presentation maybe 6 bullets or 7 bullets of more than 1,000 meter cube size. My question is, which is the standard or code you follow for such installations? Because we have a code in India, for example, which is driven from NFPA 59A and EN code, which does not allow the individual bullet to be more than 359 meter cube. And this is what the current constraint which we are facing. If you could share with me what is the code or standard which you follow for design of such installations?
I'm not sure if I've 100% acoustically got your question, but it's related to safety issues for the 1,000 cubic meter storage tank.
No, what I'm saying is in Indian codes, which are based on NFPA 59A and EN code, do not allow the small pressurized tank to be more than 359 meter cube, a single tank. Which code do you follow in your installations?
Okay, we certainly follow the international regulations, NFPA 59A in countries and EN 14620. But if there are local regulations which ask for more, we have to follow that.
But if you go through the NFP 59A, it doesn't allow a pressurized tank to be more than 359 meter cube.
Well, the
I
NFPA
would
59A
say-
has also changed in the recent time.
I am mentioning to the
Okay, very
recent-
good. But then I would say maybe we can talk in detail.
Yeah, those are some specific queries, and I'll request to connect during the tea break because but those are important. So, can we hear from Mr. Julian now once again for a wonderful presentation you made? Yeah, you want to say something? Yeah, please.
Yeah, one word. Such terminals have been built in Europe, but certainly local regulations have to be taken into account. And NFPA is now in the actual version claiming for certain distances we have to follow, and this is applicable. Clear. Okay.
Thank you very much, Julian. Yeah, that was a wonderful presentation. And I think for India, LNG holds a very strategic intervention because almost 50% of our gas requirements are being met through the LNG route. And I think in the times to come, the kind of small-scale solutions that you have given would be very, very helpful for the industry. So thank you very much for that. Yeah.
Let me give you this mic back.